Electrical analogous for mechanical system. Electrical analogous for mechanical system. So after finding the transfer function from mechanical systems, we can analyze that particular system by using electrical components. So generally we are having three types of the systems. Just I am giving some overview related to these mechanical systems. So first one is a mechanical translational system and mechanical rotational system, and after that we have discussed these electrical systems. So in this case the input is force, in this case the input is torque, in this case the inputs are, it may be a voltage source or it may be a current source. So here we can make the analogy between these two systems, mechanical translational and mechanical rotational systems, with electrical systems. So we may be having this force voltage analogous and force current analogous. Similarly, torque voltage analogous and torque current analogous. So we are having FE analogous and FI analogous, torque voltage analogous and torque current analogous. So we have to compare these four parameters, four methods or four analogous methods for the control system applications. So we'll make a tabular column, then we'll write all the parameters in mechanical translational systems, and we'll be comparing with that with respect to force voltage and force current analogous. Similarly, torque voltage and torque current analogous in case of mechanical rotational systems. So I am writing mechanical translational systems and here I am writing electrical system, here also electrical system. The input is force, the input is force, and here I am taking input as voltage source. So this can be written as force voltage analogous, and here in this case I am taking input as current. So this can be called as force current analogous. Now I am writing all the parameters. First one in this case are mass represented with capital M, and after that dash pot represented with B, spring represented with K, after that displacement represented with X, and velocity dx by dt. So in force current analogous, in force voltage analogous, mass can be represented with inductor L, dash pot can be represented with resistor, and spring can be represented with reciprocal of the capacitor. Very important bit for competitive examinations. 1 by C. Displacement can be represented with charge Q. Velocity can be represented with current, that means dq by dt. So almost the same way of representation, x dx by dt as velocity, charge q, and current is dq by dt. Now force current analogous. So in this case this can be represented with capacitor C, and resistor can be represented with reciprocal of the resistor. So dash pot can be represented with reciprocal of the resistor, that means conductance 1 by R. R you can directly write like this, no need to do confusion. And spring can be represented with reciprocal of inductance, one by L. Displacement can be represented with flux phi. So velocity can be represented with d phi by dt. That means it is nothing but voltage. So these are the analogous terms for mechanical translational system with respect to force voltage and force current method. So similarly, we can write for mechanical rotational systems, that also we can make it a tabulation. Mechanical translational system. So I am writing here mechanical rotational systems. So this side I am writing electrical, this side also I am writing electrical. Okay, now this is torque, input is torque. So here I am taking input as voltage, here I am taking input as torque, and here the input is current. So this is torque voltage analogous and this is torque current analogous. We will see what are the parameters existing. So we are having moment of inertia of mass, represented with capital J. Next, dash pot B, spring constant K, displacement x, velocity dx by dt. We'll see how these are made into analogous. In torque voltage analogous, moment of inertia can be represented with inductor. Dash pot can be represented with resistor. Spring can be represented with 1 by capacitor, 1 by C. Displacement can be represented with angular displacement theta. So velocity is angular velocity. So in torque current analogous, it can be represented with the capacitor. So dash pot is 1 by conductance, that is 1 by B. Spring can be written as 1 by inductor, 1 by L. Displacement can be represented as angular displacement only, and this is also similar to angular velocity only. So these are the analogous for electrical systems.